All right, thank you. So I'm here today to talk about using Tornado and EventMachine with RethinkDB. So if you're familiar with Tornado and EventMachine, it should be exciting for you, but if you're not, then you'll get to learn what they are. So it's going to be a pretty basic introduction. So to get started, Christine already introduced me, but I'm Ryan Paul, and I'm a developer evangelist at RethinkDB. Segfault is my Twitter handle, so you can follow me if you want to see lots of tweets about RethinkDB stuff. Before we jump into real-time application development, I want to start by introducing RethinkDB, give you a brief introduction, explain what it is that we do. So RethinkDB is an open-source database for building real-time web applications. It's also a NoSQL database. It stores schemaless JSON documents, and it's a distributed database that is easy to scale. I think that these are the three characteristics that really define RethinkDB and what it is that we're used for, what we do. What I'm going to demonstrate here today is real-time application development. It's the top item on that list. And this is a big priority for us going forward with our upcoming 2.0 release, which I'm going to talk a little bit about tonight too. So, as I said, RethinkDB is built for building real-time apps. We have a built-in publish-subscribe mechanism in the database itself. You can subscribe to receive change notifications from your database queries. What that means is that you don't have to do polling in order to get updates. So when you're building a real-time application and you want to get data from your database to your front end, you can simply subscribe to a query and push the changes. You don't have to do queries over and over again on an interval in order to find out what's changed. So this reduces the amount of plumbing that you need in order to stream live updates to your front end. Tonight I'm going to show you how to do that with some asynchronous frameworks. Now, RethinkDB, we have client drivers, like basically client libraries for connecting to the database in 3 different languages: Ruby, Python, and JavaScript. And that JavaScript driver, you use with Node.js on the back end. Node.js is already asynchronous out of the box, so a lot of real-time stuff works really well with Node, and you don't have to worry about blocking and things like that. But with Ruby and Python, the situation's a little bit different. These languages weren't really designed with concurrency in mind, and if you want to do asynchronous web applications with Ruby and Python, you need some help. So that's where Tornado and EventMachine come in. Tornado is a asynchronous web framework for Python, and EventMachine is an asynchronous web framework for Ruby. And these are event-driven frameworks that allow you to do non-blocking network I/O, which makes them really well suited for real-time web applications. You can do WebSockets and things like that, and you don't have to worry about blocking. So we wanted to make so that RethinkDB just dramatically simplifies real-time application development. We want that to be the case for any language that you use. So right now, if you're using a language like Node that's asynchronous out of the box, or if you're using a language like Go, which has native concurrency features that make it really easy to do stuff in the background, then you get a great experience. But if you're using Ruby or Python, then you really need to integrate with these other frameworks, and we want to make that as easy as possible. So in RethinkDB 2.0, which is our upcoming production-ready release, one of the big changes that we've modified our Ruby and Python client drivers in order to integrate support for these asynchronous web frameworks. So with the 2.0 release, you'll be able to use Tornado in our Python driver and EventMachine in our Ruby driver. Now, Tornado and EventMachine, we chose these because these are stable, mature, widely used frameworks in both of these languages. But we will be adding support for additional frameworks in the future, depending on what people want to see and use. So our RethinkDB 2.0 release, we have a release candidate that's available today. So if you go to our website and you go to our blog, you can see some information about that release candidate, how you can download and install it and try it for yourself. The official release is going to be in April, so we've got that planned. And we've got some events and stuff that are coming up around that. So if you check out our meetup pages, you can see what's going on and get in on some of that fun. But yeah, 2.0 is a real big milestone for us. We've been developing this product for 5 years now, and it's ready for use in production environments. And with 2.0, we're going to be announcing official support and some other things that you're going to want to hear about. So we'll have a lot more to say when we do our 2.0 release, but for now, just know that it's coming, and definitely try out the release candidate. And the features I'm going to be demonstrating tonight, by the way, will be in that release candidate. I'll talk a little bit about that later. So with these synchronous web frameworks, integrating Tornado and EventMachine directly into our client drivers, you can now perform queries asynchronously. So any query that you want to run asynchronously, you can. And the method for doing that is slightly different. Like we've historically tried really hard to make sure that the drivers are all really API consistent one to the other, so that like if you switch from one language to another, like all of it is idiomatic but also really consistent. And we kind of moved away from that for this because like Tornado and EventMachine have very specific paradigms that they're implementing, and we wanted to support those in a really optimal way. So the way that you use these, in Ruby and Python is different, as you'll see shortly. So in addition to being able to perform individual queries asynchronously, we have also made it so that you can consume multiple change feeds at the same time without blocking. So change feeds, I'm going to explain what this is next, but this is really the heart and soul of our real-time functionality. A change feed allows you to subscribe to change notifications on database queries. And what that means is that you can subscribe to a table or a query, and when the result set of your query changes, you'll get a notification in your application server. So the database will basically push a message to your application to tell it that something has changed. And like in Node.js, you do that with callbacks, but in Ruby and Python, we've got the Tornado and EventMachine integration. Previously, when you used a change feed in Ruby or Python, it would just block. You'd basically just iterate over a cursor, and then it would block until like you'd have to background it yourself. But now with EventMachine and Tornado, we've got ways to do this asynchronously. So I'm going to show you real quick. I wanted you to see like what a change feed actually looks like. So we have this query language that we call Requel, and it embeds natively in the language that you're using. What that means is that we have this sort of like query builder built into the drivers. And we have this, what you would call a fluent API, where you have these chained methods that allow you to express the queries. So in this case, what I'm showing you here is a query against a table. So we're retrieving all of the contents from the table users. And then we've attached this .changes method to the end. And that .changes method, that creates a change feed. What that does is it makes it so that you'll get a notification every time there's a change on the table. So like you add a user, you delete a user, you change a property in a user document, anything in that table, you'll get a notification in your app. Like so, as I said, the changes command returns a cursor that you can iterate over. And in each update, you get the old value and you get the new value. So let's say you have a user, and you've got information about that user, like what their office number is, and you change that office number. You'll get two versions of the record. You'll get a version where it's the old one and the new one. That way you can compare and diff and see exactly what's changed. So here's an example. We've got this simple Requel query at the top, where we're going to delete a user whose first name is Bob. And really, this would delete any user whose first name is Bob, because we're using this filter operation. So if there are multiple users whose first name is Bob, this would delete all of them. But what you see below the query is the change feed output. So let's say we had that .changes, that change feed attached to the table. What you would get out of that change feed is this JSON object with new val and old val. The new val is the updated value, and old val is the previous value. And in the case of deletion, new val ends up being null because the record doesn't exist anymore. If you were adding a record, it would be the other way around. The new val would be the record, and the old val would be null because there was no pre-existing record. So this is kind of what a change feed looks like. And when you receive these documents, you can manipulate it in various ways. Part of what's really exciting about change feeds, you can attach them to more than just a table. What I'm showing you here is a non-trivial change feed example. You can chain the changes command to relatively complex Requel queries. What we're showing here is like, say you're building a game and you want to have a leaderboard, and you want to track the players with the 3 players with the highest scores. So what you're going to do is, you would have a REQL query where you're ordering the contents of the table by an index on the score property, and you can see our desk there. We're doing like descending order, so we get the top first. Okay, and then limit command takes just the first 3. So that by itself is a standalone REQL query that you could use to fetch the top 3 players by score. But if you wanted to get like a sliding window on that, so that whenever either their score updates or whenever one user displaces another, like the contents of that list change, you just attach .changes to it, and now you're getting updates. And so this makes it really easy if you want to like wire up socket.io or whatever, or WebSockets in general, to like push this data to your front end and present it to your users. So that's a change feed. And now I'm going to show you how you would consume a change feed in Tornado, and then I'm going to show you in EventMachine. So in Tornado, what this example here does is we're looking for changes on a specific table, and we're just going to display them to standard out whenever we get a change. So it's a very simple example. And we're going to use Tornado's like I/O loop to make sure that this happens in the background. So what that means is that you can have this change feed just like constantly, like updates constantly monitored in the background without blocking the rest of your application. Okay, so I'm going to walk you through this step by step. At the top are the imports. You're importing the RethinkDB module, which is our client driver, and you're importing Tornado, which is the the Tornado module. But now the interesting bit here, that rSetLoopType method, what that does is it tells the RethinkDB driver what kind of event loop we're going to be using. So right now, the only option is, in Python is Tornado. But in the future, you'll be able to specify a different string there if you wanted to use something else. So like there are all kinds of like Twisted, all kinds of other frameworks that you could use that we could potentially integrate with in the future. And that's where you would specify which one. Okay, so Tornado has this coroutine feature, this decorator that you can attach to the function in order to configure it as a coroutine. And when you attach this decorator to the function, the yield keyword inside of it essentially works like an await command. What it does is execution will drop out of the function until the operation completes, and then it'll resume, and it'll do that without blocking. So what's nice about this is it lets you write this very event-driven asynchronous code in a way that's very flat and procedural. So like if you were doing this in Node.js, you'd have all this tree of callbacks hanging onto all those operations. But being able to use yield as an await, it flattens it all out. So first here we're going to connect to the database. And when that operation is complete, the value, the handle for the database connection will be stored in the con variable. So I've highlighted it in red. You can see the red highlighted code is what I'm going to be talking about here, and it'll flip through as I move. But the next step, we're going to perform the actual REQL query, which is just a change feed attached to the table, the table. The table is called table, so. Anyway, so you'll notice at the end of that we have .run. In the REQL drivers, you use .run to execute a query, and you pass .run a connection handle, so that we'll use that con variable that we created earlier with the connection to the database. Now, because there's a yield in front of it, basically the execution will wait until this operation completes before moving to the next. Now, here's where things get really interesting. We want to essentially iterate over the changes, the actual updates that the database is providing us. And using yield there, what that means is that execution will pop back into this coroutine every time there's something available, every time the fetch next method on that change feed produces a value that we care about. So in that loop, we can extract the change by calling feed.next, and all that method does is it takes the actual change record, like that JSON document that I showed you earlier, and it puts it into that variable and parses the JSON so you can use it. And in this demo, all we're doing is just printing it to standard out, which is not all that exciting, but that's really all you have to do there. We're going to print the document. So whenever anybody changes a document in that table, you'll see it on standard out, and this will just happen in the background. And the reason it will happen in the background is this last method call. This is a little scary looking, but what this does, this IO loop current add callback, is it tells Tornado to run the entire coroutine in the background, like persistently. So this will just execute, and it'll always be there. And whenever a change pops up, and that yield feed fetch next picks it up, then the rest of that function will evaluate, and you'll see the change appear on standard out. There are a bunch of other methods, like you can remove a callback to cancel it from running in the background, and you can kill the change feed, and there are all kinds of other things you can do. So like if you want to learn more about this, we'll have documentation on our website shortly that explains like the full range of things that you can do. This is really just like the simplest possible Python example. All right, so now I want to show you EventMachine. This is actually like beautifully concise. I'm a big Ruby fan. And the way that EventMachine works is a little bit different than Tornado. It doesn't really do the coroutine thing, but we're able to use Ruby blocks. So any event where we want to like pull in the callback, we use a block so that it's very concise and expressive here. So after our require statement here, we start with connecting to the database, and this looks pretty much equivalent, right? It's the same operation you would use to connect to the database in Python. We specify the host and the port. Okay, now here's where EventMachine comes into play. One of the idiosyncrasies of EventMachine is that in order for like a specific EventMachine method or EventMachine enabled method to run asynchronously, you need to run it inside of an em run block. Em is an EventMachine. So em.run and then a block there. Any of the contents of that block, you'll be able to use EventMachine code. And as you'll see when I show you a more complete example, you basically end up wrapping like your whole application in an em run block. But yeah, that's something you have to remember to do, because otherwise the EventMachine specific methods will not work. All right, so now we've got the query, and you'll notice that the .run method is a little bit different here. For EventMachine, we actually have an EventMachine specific run method, em_run. And what that does is it tells EventMachine to run that query in the background. So interestingly, and I'll show you this later, when you're working with EventMachine and Ruby code, for each individual query, you can specify whether you want it to run synchronously or asynchronously. And if you use that em run, it'll run asynchronously. Okay, so you can see here that we have a simple block on it, and that block will be executed every time there's a change that comes from the change feed. And all we're going to do, again, is print the record to standard out. So not a lot going on here, but simple example. You can see that we're just consuming the updates and printing them. All right, so now I want to get into like a more real-world example, how to actually build an application with this. And being a Ruby fan, I chose to do this with Ruby for you tonight. There's this really great Ruby framework that's called Faye that does like real-time pub/sub messaging, and I'm going to show you how to use that with RethinkDB and EventMachine. So a little bit about Faye first. It's an open-source publish-subscribe framework for real-time messaging, and it facilitates communication between the front end and the back end of your application. So what that means is that it has several components. There's a back-end library that allows you to write your server-side code, and then there's a front-end client library that runs in the browser that's in JavaScript, and you use them to talk to each other. So it's a little bit like Socket.io, for those of you who are familiar with Socket.io from the Node camp, in that it provides this really nice, clean abstraction for doing real-time messaging. And it's protocol agnostic, so you can use long polling or WebSockets or whatever you happen to have available in the browser, like in terms of support. So it's really seamless, and it can do handoffs between them and things like that. So it's like a really clean, elegant way to do this. Their backend framework, they support both Ruby and Node.js. I'm going to be showing you the Ruby example tonight. So here's the server-side Ruby code. This is basically what it looks like when you build a backend application with Faye and do some real-time messaging. I'm going to walk you through it here, so you don't have to read all the comments. Let's break that down, simplify it a little bit without the comments. Okay, so you can see we have that em run block at the outside, of course, but the first line here, we're basically just initializing Faye. and configuring it to use Rack and Sinatra, and we're setting a URL endpoint that it mounts to. So that URL endpoint /Faye, you can give it whatever string you want, but basically what that is it's the URL path that the client will use in order to access the messaging, the publish subscribe bus. And the rest of that is basically just boilerplate so that it works with Rack and Sinatra. And I'll show you when I get to the complete example. I integrate Sinatra so that I can have like conventional API endpoints that are like REST API in addition to my real-time messaging. All right, so the variable that we're populating here when we initialize Faye, that app at the beginning, what we use that for later is to do all the real-time messaging. There are properties on it that we use to access the clients that are connected to the server so that we can speak to them. Okay, so next we're going to connect to the database. This should be familiar to you by now. Just connecting to the RethinkDB instance. Okay, and now we're going to run the query. So the app I'm building tonight is a very simple real-time to-do list. Basically, it's just a list of to-do items. You can add them, and you can check them off when they're done. But it's real-time, meaning that every user sees the same to-do list, and you can all add items. So like imagine you're collaborating on a team, and you wanted to put together a team to-do list or something. You could use it for that. This is a very simple example, though. It's just basically like the minimum viable to-do list. So anyway, the table is called to-do, and we're going to monitor changes on that table. And whenever there's a change on that table, we're going to publish the update to a channel. All right, so channels are a concept that Faye provides. Basically, you can create like these namespaces for your real-time messages. And in this case, I named it /to-do/update. So any Faye client, like any client-side browser code that subscribes to that channel, will receive all of the messages that are published there. Okay, so now because we're running this in the block on that change feed, anytime there's an update, we're just going to like stream that update out to all of the Faye clients. So the app.getClient, what that does is it gets like basically a reference to all of the clients that are connected to Faye, and then .publish sends a message. Then the first parameter there is the channel, and then the second parameter is the object that we want to send to the channel. And in this case, it's just basically a Ruby object that it will serialize into JSON to send across the wire. All right, so this is a very simple way to do publishing updates on the back end. But okay, now you want to be able to receive those updates on the front end. So this slide is client-side JavaScript code that runs in the browser in your web application, and you would have like a Faye connect line. I actually left that off the slide. I'll show you later when I show you the full code example, but you would have like a connect to the server with the Faye endpoint. But when you want to subscribe, you just call Faye.subscribe, and then you give it the name of the channel, and then you provide an anonymous function that's just basically a callback. So whenever there's new data on that channel, that callback will execute. So in this case, we're just logging it to the console. So whenever there's an update on the to-do list and the server publishes the message, all of the browser clients that are connected to it and subscribe to the channel will pick it up and display it. Okay, so I'm going to switch out real quick. I want to show you the app, and then I'll show you the code. So can everybody see that, or do I need to make that? Let's make that bigger. Wow, the button looks a little weird at that size, but yeah. So this is just like a text input and a button. And I'm going to open two of them so I can show you side by side. And I'm going to add a to-do list item. Let's see. Let's see, publish slides from demo. So I'll remember to do it later. I'm going to click add. And you see the to-do list item appeared on both of them at the same time. So every client that's connected, it'll propagate. So now let's try checking that item. You can check that item, and you can see that it updates everywhere. You can do it on either side. Let me tighten that window a little bit so you can see. Let's check it there, and you can see that the check propagates no matter where it's made. So I'm kind of being brave tonight. I'm running this on a public address. So rethinkdemo.ngrok.com. So any of you want to go and try adding items, let's see how long we get before somebody posts something like horribly inappropriate. But yeah, like we can see the items come in. Yeah, so whenever anybody adds something, it'll update, and you can check and it'll update everywhere. So yeah, it's a pretty straightforward real-time app. Yeah. All right. So actually, I'm pleased. I like all of our to-do list items here. I plan to do. Oh, there we go. Somebody's trying to do something malicious. Thankfully, we don't use SQL, so that's not going to work here. One of the nice advantages of REQL is it kind of like protects you from a whole range of those kinds of issues. It's not string-based. But yeah. Okay. So that's clever. All right. So now I'm gonna show you the source code. I think I'm gonna have to make that bigger, huh? Okay, so I want to apologize for this like ridiculous require line at the beginning. Because I'm using this directly from the build, I have to reference the actual script. When you install this properly after 2.0 is released, it'll just be require RethinkDB. But for now, I'm loading it from the full path. Anyway, let's hide that. So after we've got the requires, there are a few things that you have to do for initial setup. Can everybody see that, or do I still need to make it bigger? Is that good? Good? Okay. So this first line, we're going to load the WebSocket adapter for Thin. So for those of you who aren't familiar with Thin, it's a Ruby application server that you can use to deploy apps that have EventMachine in them. So it's like an EventMachine compatible application server. And we're just going to tell Faye that we want to load the WebSocket adapter for Thin so that it knows that how to use WebSockets. There are a bunch of different ways to deploy these Ruby apps, and these frameworks try to support all of them. So that's what that is. Now, this code here is a little weird, where we're just like nulling out this scheme method. That's actually just to work around a bug in Faye, and the bug is actually fixed, but they haven't released the update yet. So like you won't need this code in probably like 2 weeks when they do an update or whatever. Anyway, now we get to the meat of the application. And some of this should look familiar to you because it's similar to what I've been showing you. We start with the database connection. Now here's something that's new. We've got this Sinatra app that we're embedding inside of the EventMachine block here. So what I wanted to do was create like a / endpoint that lets you get to the actual HTML page so we can serve it. So that's what that endpoint is. And then /to-do, I wanted to provide an API endpoint that just gives you the raw JSON of all of the items in the list. And that's used to initially populate the list. So when you first load the page, it's going to use an XHR request to pull in that JSON so that it knows what to-do list items are already there. And then it switches to using the real time for all of the updates after that. So Sinatra is like a Ruby framework for setting up URL endpoints and serving them, basically. And so it's similar to Express, for example, if you're a Node person. And you can see that we're defining GET requests, HTTP GET request endpoints. So /to-do, if you do a GET request on that, you'll get the output of this query. So now this query is just run synchronously. I did not use the EM run. And the reason is because we just want to block, wait for it to return the value, and then just emit it to the user. So we're just taking the full contents of the to-do list, coercing it to array, and returning it. Now, if your to-do list was really long, you would definitely not want to do like a whole table coerced to an array. You would want to do pagination or something like that, so you would chain additional methods. But I mean, for the purposes of this simple demo, it should be fine. All right, so now we're going to initialize Faye, and this is the same line I showed you before. You'll notice, though, that instead of passing a generic Sinatra app, we're passing our Sinatra app. So see, we define this class here. We're passing it into the Faye rack adapter, and we're mounting it on /Faye. All right, so now here's the code that I showed you before, where we're setting up a change feed on the table, and we're publishing all of the updates. So that I've already explained. That's all that does. And all of this uses the same connection that we defined at the beginning. I'm reusing that connection. Now here's where we get something new. Now we want to be able to receive messages from the client in addition to being able to publish the messages to the client. We want bidirectional communication. So one of the cool things about Faye is that you can subscribe to channels on the server and then use that to receive messages from the client. So app.getClient is just our reference to the client, and then we're going to call subscribe on to-do/add. And that's a new channel that we've created that we're going to use every time the user adds an item to the to-do list. So when client-side code publishes a message saying there's a new item, the server will pick it up here and add it. Now we do a little bit of sanity checking here. I mean, I don't do very much. Like all I'm doing is checking to make sure that the value passed to us by the client is just a string. I don't want people to like put some arbitrary JSON that they've typed into something and like send it over the wire, and then like we're dumping these like weird objects into our database. We want to make sure that we're just getting text. So I do some basic sanity checking there before I insert it. And then all I'm doing here is inserting it. When I call insert here, there are two properties. Those are like basically the rows in the document, the properties that we're defining in the document. The first is the text of the message, which is what's been provided by the user. And the second is a Boolean, this done property, which is whether or not it's checked. And because it's a new item that we're just adding, we're just going to assume they're all unchecked. So we set that as false. So I want to show you really quick what this looks like in the database. Nice try, guys. Okay, so we have in RethinkDB this dashboard, and it's part of the database, and it makes it really easy to manage and configure the database and run ad hoc queries and see the results. We have this feature called the Data Explorer. There's some other cool things in here. You can see all the tables that we've got, and you can see the servers that are connected. I've got like three fake servers set up. But anyway, the Data Explorer is the interesting part I'm using here. When you type a query into the Data Explorer and you click Run, you can see the output. So I'm just doing a query to see all the contents of the to-do table. So here are all of the documents that we've added as we've been typing in new items. And you can see each one gets automatically assigned a unique ID, and then they all have these properties, done and text. And the ones that have been checked, done is true. Okay, so this is what it looks like on that side. Now, like that's what happens when we insert. I just wanted you to see, like, when you do this insert operation, what it actually looks like in the database. All right, so in addition to handling insertion of new objects or new records, we also want to be able to handle the click event when somebody clicks a checkbox and the item gets checked off as done. So we're going to create a separate channel for that called /todo/done, and we're going to subscribe to it. And whenever we get a message on that channel, we're going to update the item, the record in the database, and we're going to mark it as done. Okay, so you can see here that we're getting the record by the ID. So when they publish a message from the client into that channel, they specify the ID of the record they want to check, and then the status, whether it's true or false, whether it's checked or unchecked. So then we're just going to update it with that value. And we do a little check here first to make sure it's an actual Boolean value before we perform that update, because we don't want you to put like some random string in there in the when it should be true or false, checked or unchecked. So this is kind of weird looking code, but it's the idiomatic Ruby way of checking whether something is a Boolean, because Ruby does not have a sane proper Boolean type, which I could complain about, but I won't. Anyway, the last line down here, we're just starting the server and binding it to a port. So pretty straightforward, right? I mean, you can see less than 50 lines for the whole back end of this application. There's nothing here that's really complex or surprising. And because we're routing everything through the change feeds and using Faye, the real-time plumbing is all there. You don't have to do it yourself. So let's look at what the front end looks like. I built the front end with a JavaScript framework called Polymer, which is basically like this really thin sugar layer on top of the web component standard. I'm not really using all of the exciting Polymer features in this demo. I'm really just using it for basic data binding. You could just as easily do this with Angular or React or whatever you happen to want to use. So what you're seeing here is a simple template. We're going to take that initial to-do list, like the initial values from the to-do list, and we're going to do an XHR request to fetch them. One of the cool things about Polymer is they've abstracted this, an XHR into an actual HTML element. So all this does is it's calling /todo on the server, and it's taking the JSON response and assigning it to a variable called list. So that gets us the initial to-do items. Okay, and then we're going to iterate over the list, and for each item in the list, we're going to have a checkbox and we're going to have a label. And the label is the text of the to-do item, and the checkbox is just like basic data binding to that done property. Okay, so because we're using data binding here, whenever the underlying objects that we're bound to update, the UI will change to reflect that. So what that means is if we go through that list and we select an item in the list and then we change the property of the or the value of the done property for an item to true, then the UI will update, so you get the checkbox that's checked. All right, so down here we've got this is just our input text box for new items. Then we have the button for adding the item. All right, now here's the code. This is complete client-side code, all you need in order to do this. So first, this is a Polymer thing. We're just grabbing a reference to the this to-do template in order to manipulate the stuff inside of it. Okay, then we're connecting to Faye. I mentioned this earlier. You have to use this Faye.client thing in order to connect the browser to Faye. And you'll notice we're using /Faye here, which is the path that we defined in the backend code. All right, so we have this this button for adding an item, and bound to that we have this function that just calls Faye publish, and it's just taking the text from that input and it's sending it over the channel. That's all you have to do to send that message to the backend. All right, now this is a little more complicated. We have this checkbox which has an onChange event. So whenever that change event is triggered on the checkbox, this function executes. And what it does is it gets the ID of the underlying record. Remember I showed you those unique IDs that you have in the JSON? It'll get that ID, and then it'll send whether it's checked or unchecked, and it'll pass those to the channel, through the channel to the backend. And then the backend uses those to make the modifications. So what's interesting about this here is that, I mean, in your backend code, you could have the handler for this event. You could have it broadcast here. You could do the publish event here. But by running it through a change feed instead, you get a lot more architectural simplicity here. It cuts down on the amount of boilerplate. So let's say, for example, you wanted to add REST API methods that have equivalent functionality to these real-time operations. I mean, you could have them all just do the database stuff, and then you have your change feeds propagating the events, so you wouldn't have to do the event propagation in both places. So the change feeds simplify all of this stuff. So that's how the check works. Now, this code here, this is what happens when this is the subscriber. We're subscribing to that update channel. So this is what happens whenever there's an update from the change feed and it gets passed to the front end. This is what happens. So first, what it does is it checks to see if there's already, if the item that we've received an update for is a new item or if it's an existing item. Okay, because if it's a new item, then we're going to append it to the list. And because we have data binding on that list, as soon as we append it, the UI is going to update to show it. Right? But if it's an existing item, then what we want to do is iterate through all of the items in the list, and we want to find the one where the ID is equivalent to the ID of the record that we're dealing with. And when we find the match, we're just going to update the whole item with the new value. So we get that updated value. Like, let's say you click the checkbox and you get a change, so the done property will be true. We're just going to take the done and text properties, we're going to write them over, and then it'll update in the UI. So that's all you have to do on the client side in order to receive, propagate these changes and receive the events. So one more thing I want to show you real quick. In the data management console here, the Data Explorer, you can actually monitor a change feed. So I'm going to do a .changes command here in the Data Explorer, and now we're listening for events. So whenever somebody changes something, you can actually see the update in the Data Explorer. So this is a really cool way to debug your application while you're doing real-time testing. You can monitor all of the changes as they occur right in the data console. So you can see other people making changes here. You can see those propagate. Now, you can also programmatically modify stuff in much the same way. So let me create a new Data Explorer window here. Let's say that I want to have all 3 windows. It's probably going to be tough. Let's say that I want to just like check off everything. So let's do update done true. What this is going to do is it's going to update every record in the database so that they're all marked done. And you can see the changes propagated into the Data Explorer, and they were updated in the application. So this is another great advantage of change feeds. Because you're using the change feed to handle all of the event propagation, you can have external apps and apps on different servers or whatever manipulating the data independently, and those changes will still be reflected in your application. So this basically moves the whole event propagation thing into your data persistence layer, which has a lot of advantages. So I guess that basically covers everything. This is the complete example, like a real world example that you can use this code yourself to expand it and build a real application. So if you want to learn more about this stuff, we have a lot of resources on our website. You can visit RethinkDB.com. We have a cookbook which has a bunch of great REQL query examples, so you can learn more about the query and what you can do with it. And then we have installation docs. So if you want to try this out yourself, you can install RethinkDB on your own computer or in a Linux VPS or wherever you want to play with it. And you can start working on this stuff. It's very easy to install, and it's very easy to get started. We also have a few other great reference material, pieces of reference material on the site. Like we have a 10-minute guide that will help you, start playing around. We're going to be publishing the code examples from tonight on our blog tomorrow. So you'll be able to go and see them for yourself and learn a little bit more. Thank you.